is Rachael Doyle, and I was the reporter for Group 1 for the Clapeyron experiment. The main goal was to use the Clapeyron equation and from the PT data that we tabulated in the lab, and to calculate the latent heat of vaporization, which is enthalpy. And down below you see this is the Clapeyron equation that I used during the whole procedures throughout the experiment. One of the main roles for me to do was to derive where the Clapeyron equation came from. First, if you look at the second wall, you see entropy at the saturated liquid line minus the entropy at the saturated vapor line. And you could contain the enthalpy at the saturated line minus the enthalpy at the saturated liquid line divided by the temperature. And then using the ideal gas equation, since the Clapeyron equation is used for the, in our case, ideal gas, is P-sat times specific volume equals RT. And then you plug it into the equation, and overall you do get the Clapeyron equation. So the outline for my experiment was to measure PT during boiling, starting at a very low pressure. This is what we did during the experiment. Then I plotted P versus temperature, saturated pressure versus temperatures, using the flask with the boiling beads and without the boiling beads, and then actually using the saturated steam tables from my thermo book. And then there's 3 procedures that I also had to do that all were obtained to calculate the enthalpy using the Clapeyron equation. So this is what I calculated using Excel for the pressure versus temperature. And the boiling beads is in green, and it has a little steeper slope. It boiled faster, quicker than the one without the boiling beads. And then for the steam tables, this is the red line. So they're all generically within the same range, which is good. For the first procedure, like I mentioned earlier, was to calculate the local derivatives using the ideal gas form. So I started out with plotting pressure versus temperature for without the beads in the flask. And then I took a tangent line to calculate a slope, and I picked 2 random points within the tangent line to use the slope equation. And then with the boiling beads, I did the same thing, which generally gave me around the same enthalpy value that I did calculate. And if you graph the enthalpy versus the temperature, I obtained these results. The red line is from what I calculated using the steam tables, and the green line is with the beads, and the blue line is without the beads. And you can see that they're slightly off to compare what it's supposed to look like. With procedure 2, I used Excel to obtain a polynomial function, and then used a curve fit to obtain the function. And once I have that function, I took the derivative to get the slope, and use the slope in the Clapeyron equation to calculate my enthalpies. So this was my curve fit for the flask with the beads, and this is the function that I came up with. And this is for without the beads. And my results were obviously off again. I don't know if I calculated it correctly, but it's supposed to look like the red line, and with the beads is the green line, and without the beads it's the blue line. So you're still a little off. And procedure 3 is supposed to be the best way to calculate enthalpies using the Clapeyron equation. So we used a linear equation, and we plug that in to get the equation of this form by taking the integrals of the Clapeyron equation. And then we had to solve for 3 constants, which was C1, C2, and C3. So I used the linear regression in Excel and came up with my C values. And once I got my C values, I plugged it into this equation right here. And then I took the derivative to obtain a function that I could relate to the enthalpy with the Clapeyron equation. So once I did that, I came up with this function right here. And it's still a little off compared to what I'm supposed to get, but this is so far the best way to calculate enthalpies using the Clapeyron equation compared to procedures 1 and 2. So once again, like a recap, I took the data from the experiment with pressure and temperature saturated, and then I used the Clapeyron equation to calculate my enthalpies. And this is all relevant because you could calculate enthalpies that you necessarily don't have in the steam tables. So you could use the Clapeyron equation to calculate anything that you maybe don't have right there or that you can't look up right away. So it is relevant way